sklearn, datasets, fetch 20 newsgroups vectorized. Description. This function fetches the 20 newsgroups dataset, which is a collection of approximately 20,000 newsgroup documents, partitioned across 20 different newsgroups. The dataset is pre-processed and vectorized, with each document represented as a sparse vector of TF-IDF values. Inputs. Subset a string specifying the subset of the dataset to load. Options include train, test, all, or none default. Train loads the training set. Test loads the test set. All loads both. And none loads the entire dataset. Remove a list of strings indicating categories to remove from the dataset. By default, these categories are excluded: comp, graphics, sci.med, talk, religion, miscellaneous. Data home a string specifying the location to store the dataset. If not specified, it will be stored in scikit learn data. Download of missing a boolean specifying whether to download the dataset if it is not found locally. By default, it is set to true. Return C a boolean indicating whether to return the data and target arrays separately. By default, it is set to false. Shuffle a boolean indicating whether to shuffle the data. By default, it is set to true. Outputs. Dataset and object containing the dataset. The dataset object contains several attributes, including data, a sparse matrix of TF-IDF values representing the documents. Target, an array of integers representing the target labels for each document. Target names, a list of strings representing the names of the newsgroups. DESCR, a string describing the dataset. X, a sparse matrix of TF-IDF values representing the documents only returned if return C is set to true. Y, an array of integers representing the target labels for each document only returned if return C is set to true. Steps. Downloads the dataset from the internet if it is not already present locally. Loads the pre-processed and vectorized dataset from the downloaded archive. Selects the specified subset of the data train. Test, all, or none. Removes the specified categories from the dataset. Shuffles the data if shuffle is set to true. Returns the dataset object or the data and target arrays separately depending on the return C. Parameter. Metrics. Accuracy measures the percentage of correctly classified documents. Precision measures the proportion of correctly classified positive samples among all samples classified as positive. Recall measures the proportion of correctly classified positive samples among all actual positive samples. F1 score, a harmonic mean of precision and recall. Visualization plots. Scatter plot, visualize the data points in a 2D or 3D space using dimensionality reduction. Techniques like PCA or TSNE. Word cloud represent the most frequent words in the dataset. Heatmap, visualize the correlations between different categories. Fine-tune parameters. Subset, adjust the subset of the dataset to use depending on the specific task. Remove categories that are not relevant to the task at hand. Uncertainty methods. Bayesian inference, estimate the uncertainty in the model's predictions. Monte Carlo dropout, introduce randomness in the model's weights to estimate uncertainty. Challenges and fixes. Challenge 1, class imbalance, some newsgroups are more heavily represented than others. Sample use case that resulted in challenge 1, a model trained on an imbalanced dataset might perform poorly on underrepresented categories. Fixes to challenge 1. Oversampling duplicate samples from underrepresented categories. Undersampling, remove samples from overrepresented categories. Weighted loss functions assign higher weights to underrepresented categories during training. Challenge 2: high dimensionality. The TF-IDF vectors have a large number of features, which can lead to computational inefficiency and overfitting. Sample use case that resulted in Challenge 2: a model trained on high-dimensional data might overfit to the training set and generalize poorly to unseen data. Fixes to Challenge 2: feature selection. Select the most informative features to reduce dimensionality. Dimensionality reduction. Apply techniques like PCA or T-SNE to reduce dimensionality. Regularization. Add a penalty to the model's loss function to prevent overfitting.